Hi everyone. This chapter 1, is all about data. So we're going to look at what it means to determine the context of data values. We're going to identify cases and variables in a data set, and we're going to classify those variables as either quantitative or categorical. And then finally, we're going to talk about a population and how that's different from the sample. So we're going to start off by just looking at this really small data set. It's actually a subset of a much larger data set. If you'll notice, we've got 10 rows and we have about six columns here. And I'm not including this, let me get my pencil here. I'm not including this row because that row is just kind of, or this column, because it's just counting the rows, right? It's not really part of the data set. So in this little subset, we have the title of movies. We have the month and the year that the movie was released. We have the budget for the movie in millions of dollars. And then the amount of money that the movie grossed both domestically and worldwide, again in millions of dollars. And so this data set here shows us 10 cases. So we call these cases. And then we would say that each one of these columns represents a variable. And so in this case, again, we have 10 cases and we have 6 variables. We're going to get into categorizing these variables pretty soon. That's on the next slide. But until then, we're going to talk instead more about the context of the data. So first, just generally, data is a collection of any numbers, characters, images, or any other items that provide information. For the most part, data looks like what I have here. And when we look at the context of data, we want to ask the W's, they call it in our textbook. So that would be the who, what, when, where, the purpose, and then the how. So there's like 2 whats here. But anyway, the who is going to be the individuals who were surveyed. And when I say individuals, this doesn't necessarily mean people. So in our example here, our who are the movies. What is being measured? Again, in our example, what was being measured was the month and year that the movie was released, the budget, and then the gross for domestic and worldwide. So it's the variables that are being measured. So those are the what. The when is when the research was conducted. Now, just looking at a set like this, we really have no idea. I can see here that it has a 2017 movie, so I'm assuming that this research was conducted after that year, but I don't know if further down the list there's something from the year 2020. So we really don't know when this was conducted. Where was the research conducted? Again, I can't really tell that just from looking at this, but most of these, I think all of these videos were made in the United States, or movies were made in the United States, or made with a United States company. I'm not sure about this one. But anyway, I don't really know where the research was conducted, but sometimes you can make an inference. What was the purpose of the study or the survey or the experiment? I have no idea what the purpose of collecting this data was. So that would be part of a research paper or an introduction to the data set. As well as describe how the survey or experiment was conducted. So how to take samples and conduct surveys is a topic that we'll cover in chapter 10 and 11. Sometimes you'll see an example in chapter 1 where it will tell you how it was conducted, but most of the time we're not really going to get into that yet. So let's look at the types of data. So this is a big slide. I have a lot of information on here, but we have 2 types of data that we're going to talk about mainly, and that is categorical data and quantitative data. And in this class, you're going to stick to mostly categorizing a variable as either categorical or quantitative. So a categorical variable is also called a nominal or a qualitative variable. This would be a variable that has groups, and those groups have no order. So a really good example would be favorite color. So some people might say blue, some people might say purple, red, orange, whatever. But blue is not better than purple, and purple is not better than orange. There's no way to order the categories in any way. So these types of categorical variables, they're your most basic variables. There's no order to them, there's no unit to them, and they can be put into groups. Now, there's two other categorical type variables, which is ordinal and identifier, but I'm going to come back to that after I talk about quantitative variables. So quantitative variables on the other side are variables that can be measured, and they have units. So things like height or weight, something that's measured in inches or feet or kilograms or whatever, but it has a unit of measure. That unit of measure is not always obvious. So for example, say I had an example where it had a list of items, right? The number of items purchased. And it would be a quantitative variable, but when I asked people what's the unit, a lot of people couldn't tell me. And the unit was items, right? So number of items purchased. I purchased 6 items. So items was the unit. So you got to be careful with trying to identify units. Sometimes they're not always units that are obvious, like centimeters or dollars or something like that. We do have 2 types of quantitative variables, and we don't get into it too much in this class, but there's discrete versus continuous. So discrete means countable, something like the number of TVs in your house. You can't have half of TV. So maybe the answer is 2, maybe it's 3, maybe it's 5, but it's a countable number and there's no fractions. Whereas continuous would include any kind of fractions between those whole numbers. So height, for example, is a continuous variable because you can be 5'4", you could be 5'4.5", you could be 5'5", and so on. The big thing with quantitative variables is that we can calculate statistics. Statistics like a mean or a median or a standard deviation. And a lot of times when I'm trying to decide if a variable is quantitative or categorical, I don't always think about whether or not it has units, and I more often think about whether or not it would make sense to calculate the mean for that variable. So I do have some examples here. Something like number of mobile devices, that would be a discrete quantitative variable, whereas weight would be a continuous quantitative variable. But for all of these, regardless if they're discrete or continuous, finding something like a mean would make sense. So now I'm going to go back and talk about ordinal variables. And you want to be very careful of ordinal variables. So they are categorical variables, but they're categories that have order. So think about like letter grades in a class. So there are categories, A, B, C, D, F, but an A is better than a B, is better than a C. So those categories still have order. Another example of an ordinal variable is a Likert scale, which you've seen these a lot actually. It's something like satisfied, very satisfied, dissatisfied, very dissatisfied. That would be a Likert scale. Now, I say inconsistent spacing because think about, the difference between satisfied and very satisfied might not be as big, if you could measure it, as it would be between, say, satisfied and dissatisfied. So sometimes in a Likert scale, they're not evenly spaced, and sometimes they are. So, or ordinal variables. So like a letter grade, they are evenly spaced. The other thing with ordinal variables is that sometimes it makes sense to calculate a statistic, like a mean. So, for example, this happens all the time with your letter grades, right? If we assign a number to your letter grade, which we do, we say an A is a 4.0, a B is a 3.0, and a C is 2, and so on. And then we calculate an average, and that's how you get your GPA. So sometimes it makes sense to calculate an average of an ordinal variable. Now, GPA itself, I don't want to confuse anybody. If I were to collect data on GPA, a GPA is actually a continuous quantitative variable, but the letter grades behind that GPA would be ordinal variables. You'll also see with Likert scales, people will say things like, rate this on a scale from 1 to 5. So that would be an example where you might want to take an average because you want to say, oh, most people said this was a 4 or the average was a 2. That's going to give you some information about that data. And finally, there's the identifier variable. We had an example of this on the last slide. The movie name was unique to each case. It's still a categorical variable, but there's only ever one case in each category, and that's because the identifier variable is unique to each case. So it is a variable, and some people tend to leave it off as such, but it is considered a variable. It's just not an interesting one since it's unique to every case. Another example would be order number, right? Everybody has a different order number for every order. So it's not an interesting variable, but it is an identifier variable. Okay, so a couple of things to note. So it's really important to think about how you're categorizing variables. You want to think about what they represent. So a really good example here is to think about age. So how can age be collected so that it would be a quantitative variable? And how could age be collected so it is a categorical variable? Quantitative is pretty easy. Somebody's 30 years old or 18 years old or 45 years old. Those are measured, the units are years, and it would make sense to find, say, a mean for those values. So that would be age as a quantitative variable. But we could also express age as a categorical variable. Think of like baby, toddler, teenager, senior citizen. Those are all categories. You could also split age up and put the values in categories. So you've probably seen this on surveys where you have to check the box. Are you age 20 to 29, 30 to 39, 40 to 49? So it took those values and created categories. You also want to be careful and don't assume that just because a variable is labeled with a number that it's automatically quantitative. So zip code is a classic example. So a zip code, so even though it's labeled as a number, so here's the Ellicott City zip code, it doesn't really mean anything quantitatively. A zip code just talks about an area. And I think way back in the day, those numbers used to mean something, but they really don't anymore. And taking an average of a set of zip codes would mean nothing. It would give you no information whatsoever. So a zip code is a categorical variable. It's not quantitative. So let's look at an example. So I have an example here. It says in June of 2012, Consumer Reports published an article on some sport utility vehicles they had tested recently. They reported some basic information about each of the vehicles and the results of some tests conducted by their staff. Among other things, the article told the brand of each vehicle, its price, and whether it had a standard or automatic transmission. They reported the vehicle's fuel economy, its acceleration, which would be the number of seconds to go from 0 to 60 miles per hour, and its braking distance to stop from 60 miles per hour. The article also rated each vehicle's reliability as much better than average, average, worse, or much worse than average. So the first question here is for us to describe the W's given. So let's start with the who. And we're going to say who is being studied. Remember, this doesn't necessarily mean people. So in this case, the article is all about SUVs. So this would be the sport utility vehicles. The what I'm actually going to put over here because the what are all of the variables. And I'm going to list them because we're also going to then classify them as either categorical or quantitative. So the variables we have, let's see here. We have the brand, we have the price, we have the transmission, we have the fuel economy, the acceleration, the braking distance, and the reliability. So let me write those out. So we have brand, price, transmission, fuel economy, acceleration, braking distance, and then reliability. All right, I'm going to classify those in a minute. Let's go back to the other W's. So we also want to discuss when. It doesn't really say specifically, but the report was put out in June 2012. So it had to be before this time, but probably not way before this time. So we're going to say near, but before June of 2012. So that's, again, the when is asking when the study was conducted. The where, it does not specifically tell us where, but Consumer Reports is a company in the United States. So I'm going to assume that this is probably the US, but I'm guessing here. I'm making an assumption. The how was this study conducted? So we don't have a lot of information here. It didn't say that the sport utility vehicles were randomly selected. It doesn't say much about that. It just says that they collected some basic information and they ran some tests. So we're going to say they ran tests and collected basic info. And then the why. Why was this data collected? Well, Consumer Reports is an organization that is for customers. So we would say that the reason that they probably collected this was to give information to potential customers. All right, so let's go back and talk about all of these variables and let's categorize them as either quantitative or categorical. So starting with brand, brand of a vehicle, this is definitely categorical. And just your basic categorical. There's no one brand better than another, I mean, so to speak. Price, so the cost of a vehicle, that's going to be quantitative. Let's get my too many eyes here. The transmission, there's two types of transmission, standard and automatic. So that is a categorical variable. The fuel economy, so that is in, what's the unit? I can't remember. It's late, but this is definitely quantitative. Acceleration, and it says that the acceleration is the number of seconds to go from 0 to 60. So this is also quantitative. And this is in seconds. And the same thing with braking distance. And then the reliability, they discuss as being much better than average, average, worse, or much worse than average. So this is categorical. And an example of that Likert scale. So this is an ordinal categorical variable. You do not have to do that. In our class, you only have to say if it's categorical or quantitative. Okay, so looking at, hold on, it's gonna make me take my pencil away. There we go. Looking at the next slide, this is just a little bit more vocabulary, and then I'm going to do one more example, and then we'll be done with chapter 1. So first of all, just as we move forward, cases usually are a sample from some larger population. And again, how we take those samples is something that we'll study in chapter 10 and 11. But usually we take a sample so that we can understand a larger population. And for that reason, we want our sample to be representative of that population. Now in this class, we'll talk about 2 different types of study of statistics. We have descriptive statistics, which means that we calculate things like mean and median, and we make graphs. And then we have inferential statistics, which is when we use samples to make inferences about a population. Our unit 1 is descriptive statistics, and our unit 3 is going to be the inferential statistics. But we will use the words population and sample a lot in this class. A few more vocabulary words here. Respondents are people who answer a survey. Subjects or participants are usually people who are part of an experiment. And if it's an experiment and they weren't people that were part of the experiment, we usually say experimental units. So like say there were rats that were part of an experiment. So instead of saying subject, well, I think you could still say subject, but they might call rats experimental units. And then records are rows in a database. So a lot of times we look at records, or we take a sample of records. All right, one last example here. So here it says we have coffee stations in offices often ask users to leave money in a tray to pay for their coffee, but many people cheat. Researchers at Newcastle University alternatively taped 2 posters over the coffee station. For 1 week, it was a picture of flowers. During the other, it was a pair of staring eyes. They found that the average contribution was significantly higher when the eyes poster was up than when the flowers were. Sorry. Apparently, the mere feeling of being watched, even by eyes that were not real, was enough to encourage people to behave more honestly. So in this case, we're looking for the who and the what. So this was an experiment. And again, we'll talk more about experiments when we get to chapter 11. But the who of this experiment were the people using the coffee station. And apparently this was at Newcastle University. So this is people using the coffee station at Newcastle University. Be careful when you're answering these questions because you want to make sure that you're very specific. Notice I didn't say people who drink coffee because there might be plenty of people who drink coffee that buy coffee at Starbucks before they go to the university. So this is specifically people who are using the coffee station at this specific location. And then what? What is being measured here? The what that is being measured is the amount of money that people are leaving after taking some coffee. So amount of money people are leaving after taking coffee. And this is on the honor system. So they totaled up the amount of money when there was a picture of flowers, and they compared that to the total amount of money when there was a picture of staring eyes. So the next question says, what is the population of interest? So by doing this experiment, what is the group of people that these researchers are trying to understand? Are they trying to understand coffee drinkers? Are they trying to understand people who attend this university? I would argue that they're trying to understand all people who are asked to be honest, right? So it's bigger than that. The population that they're really trying to make some kind of inference about is all people who are asked to be honest. Okay, that is the end of chapter 1. Please let me know if you have any questions.